a few of these problems from the homework. So basically, let's read what we have here. Let's see how to do this because it's the same thing for both of these. It's the same idea, and it's nice to know how to do any of these types of problems. So what's important is that first we realize that we're allowed to use our calculators for this, and it's going to be absolutely necessary that we have our calculator and we know how to use it for a problem like this. So the first thing it says is g is a differentiable function and g of 4 is this value, and it gives you a derivative of g, and then it asks for the value of g of 1. Now the way you could do this is you could use the fundamental theorem. You could say that the integral from 1 to 4 of g prime of x dx, and this is just the evaluation theorem. It says g of 4, right, some antiderivative of g prime minus g of 1. And we should just remember that an antiderivative of g prime is g, right? If we have that in our minds, then this formula comes out to us right away. And with this, we can then kind of find out what exactly g of 1 is. That's what we want. We want g of 1. And the way we would do that is we would just find out, we would use our calculator to find out what 1 to 4 is of this whole crazy function, 1 over x e to the negative x cosine x over 100, right? This whole thing. You'd use your calculator dx. You'd use your calculator to find what this is. And then they give you that g of 4 is 0.325. And you want g of 1. So what you would do is you'd subtract on both sides. You'd get that g of 1 is equal to. And again, you got to use your calculator to find out this value. Let's call this value z just for easy sake. So this would be 3.25 minus whatever that value of that integral is. Let's call it I for integral. The value of this integral. Again, use the calculator. If you don't know how to use the calculator, find out how to use the calculator to find a definite integral. The calculator does something called numerical analysis to find out what this integral value is. Don't worry about it. All you need to know is that you can use the calculator and how to use the calculator to get this integral. And g of 1 will equal whatever that integral is, or 0.325 minus the value of that integral. And similarly, this problem, same idea, just different values, different functions, and different bounds for my integral. Again, by the fundamental theorem, I have that from 0 to 2 pi of f prime of f of x, f prime of x dx is equal to an antiderivative f prime, which is just f evaluated at the top bound minus f, the antiderivative evaluated at the lower bound, 0. And in this case, I'm given f of 0 is 5.42, and I'm looking for f of 2 pi in this case. So I would add this over to the other side, and I would get the integral from 0 to 2 pi of whatever this is, the square root. And again, you got to use the calculator. Sine squared x plus x dx, right? That's f prime of x. It's sine squared x plus dx. I would use the calculator to find out that value. Plus, right, I'll add the 5.42 onto both sides. And this would allow for me to solve for a value of f of 2 pi. And again, you just need to know how to use the calculator to solve this integral. This here. Just the same way you needed the calculator to find this definite integral. And that's it.